passive component we'll be looking at is resistor. And the resistor is defined as that passive component that limits the flow of electric current. So we describe resistors as those passive components that limit the flow of electric current. The electrical symbol for the resistor is this, R for resistance. Now let's assume that this is point A in the circuit and then this is point B. Let's say at point A in this circuit you have a 5-volt signal at 100 milliamps passing through this resistor to a point B. We get to see that depending on the value of this resistor, at point B the signal may have become 3.5 volts at 50 milliamps. The amount of resistance offered by this resistor determines how much current we get to see on the other hand. And as current passes through a resistor, there will always be a drop in voltage according to Ohm's law. So we describe resistors technically as passive components that limit the flow of current. The amount of resistance determines how much current you get at point B after the signal coming in from point A. Now to usage. What use do we put resistors to in an electronic circuit? We put resistors to 3 usages in electronic circuits. The first usage is that we use them to limit the flow of current. Secondly, we use resistors to cause a drop in voltage. And thirdly, we use resistors to create a varied voltage. So when you get to see a resistor in this circuit, it is possible the resistor is actually doing 1 or 2 of these in a circuit. It is either the resistor is limiting the flow of current, or the resistor is causing a drop in voltage, or the resistor is creating a different voltage from what we already have in the circuit. A good example to illustrate the usage of resistor is in an indicator module. In an indicator module, when you turn on any electronic circuit, any electronic device, there will always be a power indicator. There will always be a power indicator to indicate that the device is powered on. And such indicators are implemented using light emitting diodes. The light emitting diode will emit light once there is power supplied. I have a good example here in my cordless screwdriver power adapter. This is used to charge the battery of my cordless power adapter. This is plugged to power, and that is why this indicator is coming on. But the output of this adapter that is used to charge the battery for the cordless screwdriver is 24 volts at 1500 milliamps. So in other words, the manufacturer of this adapter has here a 24 volts at 1500 milliamps. But then such indicator module will always have a light emitting diode, in most cases a 5 mm light emitting diode that will not take in more than 1.7 volts as maximum forward voltage and the maximum forward current of 10 milliamps. In other words, the manufacturer of this light emitting diode specifies that the maximum voltage you can apply across this light emitting diode must not be more than 1.7 volts, and the current that must be flowing through this light emitting diode must not be more than 10 milliamps. But yet the manufacturer of this adapter needs to help us know that the device is powered. So in other words, he or she would need a resistor to drop the voltage getting to the LED from 24 volts to not more than 1.7 volts and reduce the current flow, limit the current flow to 10 milliamps from 1500 milliamps. So the resistor used in this circuit here will be limiting the flow of current and causing a drop in voltage. So to help us get the value of the resistor, then we'll use Ohm's law, we'll apply Ohm's law rather. So from Ohm's law, we get to obtain the value of the resistor needed by dividing our voltage by the current. In this case, the voltage is 24 volts coming in from the adapter. The lead needs no more than 1.7 volts, so we subtract that from 24 volts and divide it up by 10 raised to the minus 3 amps. That's the 10 milliamps. So if you compute this, we will have 22.3 volts multiplied by, let's take this up, 10 raised to 3 divided by 10, and if we further compute, we'll end up having 2,230 ohms. 2,230 ohms. Now, by way of design, this is the minimum value of resistor we are to use. We are under obligation to use something higher, and that is because while calculating, we had worked with maximum values. So using a 2,230 ohms resistor, with that maximum voltage of 1.7 will get to the lead, and maximum forward current of 10 milliamps will get to the lead. And if that is happening on a power indicator on a device that's going to be used almost all day, eventually this lead will get damaged within a short while because it's getting not the maximum voltage and not the maximum current. And as a designer, while designing an electronic circuit, three things will always guide you. Number one is reliability. You want to design something that is reliable, something that can be used for a long time, not something that after some few days they will return back to you as not working. So you want to design something that is reliable. Then secondly, you want to design something that is compact or as much as possible weightless. And thirdly, which is always the last thing we consider while designing a circuit, is cost. You want to design something that is cheap for you, the engineer, to implement and affordable for your clients, but without compromising on reliability. So coming back here, on the side of reliability, we are under obligation to use a value of resistor higher than this, so that we don't get the maximum voltage and maximum current getting to the lead. So with that, if I'm designing the circuit, I'll be using 4,700 ohms. With that, I'll be ensuring that not the maximum voltage and current will be getting to the lead, so the lead is going to last long. The third thing we put resistor to use in a circuit is to create a different voltage, and with that we are referring to resistors being used in a voltage divider. This is a typical voltage divider where you have a particular input voltage and you desire to have a particular output voltage, so you need resistor R1 and R2 to help you divide the voltage. In that case, let's take a simple example. Let's say you have a 12 volt source, and in that same circuit you intend to generate a 3 volts. You can use resistors to help divide your 12 volts to 3 volts. When you apply this formula, a voltage divider rule that states that your V out is obtained by dividing your R2 with the sum of your R1 and R2, then multiplying it with your V in. So for example, in this our example here, we have a 12 volts V in, and then we desire to get the 3 volts from it. So we need to choose resistors value, where the value of resistors that will help us divide the voltage. So in that case, if you look in here, we can have this to be V out divided by our V in equal to R2 all over R1 plus R2. We can then put the values where we have 3 divided by 12, which gives us 1 divided by 4 equal to R2 all over R1 plus R2. So from there we can have this cross multiplied to give us 4R2 equals to R1 plus R2. And when we bring this over, we have 3R2 equal to R1. So let's assume our R1 is 10K, and then we look for our R2. So our R2 will then be equal to R1 divided by 3, which gives us 10K divided by 3. So with that, our R2 will be 3.3K. So what we are saying here is that with a 10k resistor here and a 3.3k resistor here, once you bring in a 12 volts, at this point in the circuit, we will obtain a 3 volts. So with that, we've seen the resistor helping us to create a different voltage from what we have in the circuit. What we have in the circuit is 12 volts. We want to, at some point in the circuit, generate a 3 volts. Then we can have these resistors used to help do that for us.